Hi, my name is Julia Silge, and I am a data scientist and software engineer at our studio. And in today's video, we're going to use a data set from the Claremont Run Project, which is an academic project studying a run of comic book series about the X-Men, the Uncanny X-Men, and we're going to use data from this project that counts up how many times different characters speak and think and are portrayed in different ways, and then use bootstrap resampling to train models to understand some things about these issues. We're going to train two different models and show how we can use the same approach to understand different things about these issues. First, we're going to train a model to look at the locations of the issues and say, can we understand if issues that take place in the X mansion are more likely to have different characteristics in terms of how characters are portrayed. And then also we're going to look at the Bechdel Test, which is a measure of how women are portrayed in media, and see if we see differences in these issues in how characters think, speak, and act or portrayed, depending on whether they pass the Bechdel test. So let's get started.
Okay, here we are. Let's get started with this. So this data from this week is from a long-running comic book series. The Uncanny X-Men, as it was called then. And there's this academic project called the Claremont Run Project, where they have collected and curated quite a bit of very interesting data about these issues of these comic books. And so there's quite a bit here to explore. So one of these data sets here has many rows of data for these. Not all the issues are in this data set, but we can see how many issues do we have this detailed information for. So we start around issue 100 and go about to issue 300 or so, and we have for each of these issues we have information about how characters are portrayed. What do we see them doing? So we have, we can see who, let's do a distinct character. So who is in this data set? Whoops, oh, did I do it wrong? Summary. Let me try that again. Character, visualization, distinct character, like so. Okay, so we've got 25 characters in here. So this data set has for the main 25 characters Wolverine and Cyclops and Storm and these like most important characters in here. It has for every issue when they are portrayed in costume and then also not in costume, how many times do they speak? So how many speech bubbles are there? How many times do they think? How many thought bubbles are there? How many narrative statements are there about them? And then how many total depictions are there? There are some issues that it turns out are about other not these main characters. So there are actually like if we were to look at what was it called? Depicted, let's say lesson 1. There actually are quite a bit of well, this is for these characters, but we can see what's going on with that. So that's one data set, like per issue, per character. How do we see them portrayed? Are they thinking or speaking, or are they doing something? And then we've got a couple other data sets here. There were actually multiple in this week's Tidy Tuesday, but we are going to work with 3. So the next one is this locations data set. So it has for every issue, what are all the locations that are in it? So this first one, it takes place in space, in a dream, and then the X Mansion in the present, and these other places. So we can say what are the top locations in these issues. So the X Mansion appears the most, perhaps unsurprisingly, but there are lots of other places as well, lots of other locations that we see here. And let's check out, let's say, so locations, let's say group by issue, and then summarize is let's call this new variable mansion, and we'll say is the X mansion in location, like this. And then we can say, okay, so yes, they are in the X mansion in these first three, but then in 100 it is not. So locations, let's filter to episode, no, why do I keep saying episode? Issue equals 100. They are in space in issue 100, so they are not in the X mansion. So this right here will tell us which issues take place at least partly in the X mansion and which don't. So like what happens in issue 101, they are in a lot of airports. They are just traveling around. And they end up in a hospital. Oh no! Who knows what happens there? So this dplyr statement here will help us find out which of the issues take place in the X mansion. So let's use that for one of these models that we're going to train here. And then the other data set that we'll come back to at the end is this data set on the X-Men Bechdel. So for all the issues here, so you notice we've kind of got a different set of issues in each one of these data sets. So we're gonna have to be doing some interjoining there. But for this one, so for these issues, does it pass the Bechdel test? So the Bechdel test is a kind of a heuristic for kind of assessing gender representation in fiction. So something passes the Bechdel test if there are two characters who are women in this piece of fiction, and they talk to each other about something that is not a man. So it kind of is, like was originally like tongue in cheek, like surely this is like some kind of bare minimum in terms of gender representation in fiction, right? That there's like two characters who are women who talk to each other about something who's not a man. But it's kind of an interesting way of assessing overall, like what kind of stories are being told. So it's a sort of common way of talking about representation in fiction. Kind of a heuristic way of talking about what fiction is like. And so we will down here we'll come down to the Bechdel test down here. So what we're going to do is we're going to be training some models using bootstrap resampling, because this data set is small, and I could train a model like on a per issue basis, but there are not that many, issues here, and I would like to use the most robust statistics that I can to understand how sure am I when I get some kind of result. So I'm going to use bootstrap resampling to be able to do that. And so I'm going to come back to this character visualization data set. Let's remind ourselves what it looked like here. So this has many rows because this is aggregated at the per issue, per character, per costume level, and I'm gonna aggregate this all up. So I'm gonna group by issue. So what I want to know is, in every issue, is there more, or like how many speech bubbles, thought bubbles, narrative statements, and depictions are there. So there are, this is, just to remind us, this is for the top 25 characters that are included in this data set. So I'm going to use a summarize, so group by summarize. And then what I'm going to do is, I want to summarize these 4 columns. So I'm going to use the across function that is in dplyr 1.0. I'm going to say across these 4 columns, I want to take the mean, like so. And then I think I need to ungroup. I can't remember. Like this. So let's save this as per issue. So I had something that was per issue, per character, and even in costume versus not in costume. And I want to, I did not like that. Speech depicted across, let's see. So character visualization here. So I've grouped there, summarize, across, speech depicted. I've got my across. If we want to look at, my mistake was with how to use across. I'm fairly new to across, as you might be. So across, the function is inside of across. So we want to summarize across the whole. You summarize across the whole across. And the first argument to across is the columns, and then you put in the function. So it goes like this, like so. So per issue. Now we have a data frame that has, for all the issues that we have in this data set, which is just shy of 200, how many speech bubbles were there, how many thought bubbles were there, how many narrative statements, how many depictions of these 25 most important characters. Okay, so now let's call this X mansion, like this. So this is a logical, for each X mansion is logical true, false, does it or does it not take place in the X mansion. And then let's join those up. We'll say per issue inner join X mansion, like this. And let's call this locations joined, like so. So locations joined looks like this. So I've got the issue, these 4 things, and then mansion. Like, does it take place? Does that issue have the X mansion as one of its locations or not? And now let's make one visualization here so we can see what's going on. So locations joined. Let's see. I'm going to say mutate mansion if else. So if it is the mansion, let's say X mansion, because this is going to go probably on the X-axis. So I don't want true falses there. I want like some words. This is currently kind of wide, and I want it all to go on one plot. So I'm gonna pivot it longer, so instead of it wide, and I want to pivot those same 4 columns, and I want, let's call it I don't know, I can give it a better bit names. Like this is it was called character visualization. So this is how are characters visualization. And now I can pipe this to ggplot. So mansion, here I'll just show what that, let's make sure it works. Okay, so we have per issue, was there an X mansion or not? And then how many of each of these things are there? So we're going to put mansion on the X-axis, that value on the Y-axis, and then let's fill visualization. And let's put, let's start with a box plot. I don't need the legend. And let's facet wrap. and by visualization. And let's look at that. Okay, so this is a good start. We don't need that Y label or the X label, and let's the scales are on fairly different X and Y axes, so let's do this. So we've got box plots here. We can kind of see where the median is. Depiction is a bit higher. Speech, it's hard to see where some of these, because these are small numbers. This is actually small data, and with small data, it's nice to just see it, like where actually is it. And so I like to switch out for a dot plot like this. The dot plot, I'm not as familiar, I don't use it like every day as much because it's really best for when you don't have a ton of data. So I think what I'm going to have to do is, I think I have to say the bin axis is Y here, and I want to stack it to the center like that. Let's see if that does it. Yes, nice. All right, let's look at this. Okay, so I like a nice dot plot. I like to be able to see. It's like a nice way to be able to see the actual data. It's pretty good. So now we, it's still kind of off the edge. I wonder, there's one more thing I feel like. Bin positions. What does it do? Okay, let's try that. It's like bin, all, bin positions, all, so that it, makes them all together versus that's what we want. All right, come here. There we go. Very nice. That's perfect. That's very nice. Okay, so here we can see where the actual different comic book issues fall. So the ones that take place in the X mansion are over here. The ones that are not in the mansion are over here. And we can see, we can see the shift in the depictions. And it's hard to understand really these other things because the numbers are kind of low. And I would rather use, like, this isn't something I really want to just kind of guess by eye. Like, I would like to use some more robust statistical methods to do so. So let's do it. So let's load tidy models. We're going to use the bootstrap. Let's load it so I can have my precious autocomplete. So we're going to use the bootstraps function, and we are going to bootstrap that locations joined data. We want a ton of them, right? Because this is the idea here. We're gonna say, let's say 1,000. We could probably go up to 2,000 or 5,000, but this is enough for now. And we want to set apparent equals true because we are gonna do some. We're gonna use some functions that need if we want to look at what bootstraps. Let's bootstraps here. What apparent equal is, should we add an extra resample that is just the entire data set, and that's we're using our bootstraps to do some robust estimation, and so we actually need the whole data set in this bootstrap here at the end. Let's call it just boots like this. Let's set a seed, because this involves like randomly resampling. So as a reminder, bootstrap resampling is it's the same size. So if locations joined is 183, when we bootstrap resample, we're going to end up with 183 at the end, but we're going to be drawing with replacement. So there'll be duplicates. So we issue 103 might end up in there 3 times, and 102 won't ever end up in some given bootstrap resample. And so we make 1,000 different bootstrap resamples of this data set, and then if we fit models to all of those bootstrap resamples, we can get a more robust estimation of what any effects are that we can see. So that's what we're about to do here. So we're going to take our bootstraps, resamples, and we're going to use mutate here. So let's call it model, and we're going to use map from the per function. So what are we going to map on? So let's look at here. So boots. Oh, I never did it. So boots here has these splits. So like if I look at the first split, there are 183. It's the same number. This is the original. This is the analysis. Or for example, I could, if you want to look and see what it looks like, I can say analysis. Use the analysis function here and get it out. And notice that they're all scrambled up in order, and also we have duplicates. And also some of them will be missing. And the ones that are missing are in the assessment set here. Okay, so I'm gonna, the first thing I'm gonna do in the map, the first thing I do is the splits. So that's what, so map, the first function is the thing you're mapping over, and then the first argument, excuse me, is the thing you're mapping over, and the second argument is the function that you are going to map over with. So we're going to build just a little model. We could write this with Parsnip from the Tidy Models framework, but I'm just going to write it with plain old GLM. So I'm going to say mansion, true or false. It is going to be predicted by speech plus thought plus narrative plus depicted. So which of these is more like makes it more likely to happen in the X mansion, and which of these makes it less likely to happen in the X mansion? I'm going to say family equals binomial, and I'm going to say the data is going to be equal to the analysis of the dot, and the dot is the thing that's being sent in here, and I use this little tilde here. Okay, so that will train all my models. Let's see, so that's a map. And then let's do another map. Let's get some coefficients out, and we're going to do a map, and we're going to map on the model, and we're going to tidy it like this. So we're going to say, and let's save this. I think I got this all right. Let's call this boot models, like so. I got something messed up. My parentheses are unhappy. All right, now my parentheses are happy. Let's see if that works. All right, so now it's training 1,000 logistic regression models. Fortunately, any one individual model is not very big. So now we have the models are here in this column, and now the coefficient info is here in this column. So let's get that out. We can unnest the coefficient info if we would like to see it, like here. So we can, so for every speech, thought, narrative, depiction, we have a model. So we have these models for every single one of them, and they have standard errors and so on. So now what we can do, the R sample, the Tidy Models package that has support for all this resampling and stuff, has a function called int. I think I use this one. Percentile has functions for bootstrap confidence intervals. So if we do this interval percentile, we send it a data frame containing the bootstrap samples, which is what we have, and the statistics. Where are the statistics? So for us, we're going to say int percentile. So the bootstrap confidence intervals, and we're going to say here are the here's our bootstrap results, and the coef info. Remember, our results are right there. So here we go. So here's the estimate, but we're interested in these lower and upper things, right? Lower, upper. So depicted is positive, narrative goes around 0, speech goes around 0, thought goes around 0. So it looks like depicted is really the only thing that is very important here for us to look at. We can boot. Oh, let's save this. Boot like this. All right, boot. And now let's actually, we can actually plot those distributions of all those different coefficients that we had and look at what the results are. So we can say, let's say the estimate, what was it? Estimate, and then let's just make histograms. Let's say fill equals term, and let's put histograms. Let's make them a little bit transparent, and let's say like 25 bins, and we don't need that legend because we are about to facet wrap the term. And let's just do scales equals free like this. All right. Okay, I don't need the intercept, so let's filter term not equal to, intercept like this. And let's add a vertical line. Oops. Let's add a vertical line. It's going to be at 0, so we can see where the 0 is. And let's make it like gray and dashed and transparent and kind of thick. That should be nice. And a plus. Oops, too many commas. There we go. Let's look at that. All right. Let's look at what we have here. Okay. All right. So for these 4 kinds of things that can happen in comic books, for the 25 most important characters, they can speak, they can think, they can be portrayed in a narrative sense, or we can see depictions of them. So the strongest effect is both in terms of effect size and in terms of how sure we are that it is real, is this depiction. So the more, and it's positive, so the more depictions there are, the more likely some issue is to have a location in the X mansion. So I think this makes sense. Instead of people going off on like little solo adventures or whatever, or with a small group, they're all together in the X mansion. So we see lots of depictions of characters, lots of them together in the X mansion. The speech one is we're less certain we see an effect there, but I still, I would be willing to say I think there's something real here. So the speech one is negative, and that means that in an issue, the more speech bubbles there are, the less likely something is to take place at the X mansion. So these things are in opposite directions, whereas the effects from narrative and thought are, see where the 0 is relative to the peak of these distributions that we see. We do not see any impact from thought bubbles or from narrative statements. So we used bootstrap resampling to be able to measure the impact of these 4 kinds of ways characters are portrayed on whether the location had the X mansion, the X mansion was in it or not. So that's great. Let's do that whole same thing, but for the Bechdel test. So let's copy this. Let's put it here. So we are going to join this here instead. I think I am going to turn that into from a yes, no to a true, false. So let's use let's see, we're just going to add it here. Mutate, pass, Bechdel. Let's use the same kind of if else. So pass, Bechdel, yes. We'll call it true, if not equals false. So that way we can just, like, this will all be so much the same. And then, let's see. And let's call this passes Bechdel. And let's call it no Bechdel, like this. All right, let's zoom in here. Whoops. Okay, and so we can see, again, here we can kind of look at where the data is. It looks like we've got, you know, maybe more speech up here, but again, it is hard. It is hard with this small. He's like when the number of issues is this small that to be able to see this as concretely, and I would prefer to use the bootstrap link to see it, to be more sure that I'm not fooling myself with these particular plots. But this is very important to be able to look at our data in this way. So let's copy the thing here that does the modeling. So, oh, you know what? I'm going to just call this Bechdel joined. Bechdel. So we got that. Let's call this here. And instead of predicting mansion, we're going to be predicting pass Bechdel, like this. So now it's training another 1,000 models. And now let's see what we have here. So this is again those bootstrap confidence intervals. So it looks like depicted as negative now. We've got a few things that are very again close to 0. And this one looks like it might be interesting. So that will be interesting to see. So let's let's copy this and make the same plot that we made before, and we'll be able to and this is the same, so this should all be the same, except that our data is now about predicting the Bechdel test. Okay, this is interesting. So okay, so the one that is the most clear here is speech, and it's positive. So unlike with the X mansion, it is now positive. The more talking there is, the more likely it is to pass the Bechdel test. So there's the more characters are talking in speech bubbles all together, the more likely two characters who are women are to talk to each other about something that is not a man. So nice. I like that result. I think it's good. And what else do we have here? Depicted is negative. So the more characters there are in, like, more depictions of characters there are in an issue, the less likely there is to pass the Bechdel test. So issues that have just tons of characters in them are less likely to have two women talking to each other about someone who's not a man. So that's kind of interesting. Narrative and thought. Narrative certainly, like, I don't, I'm not going to stake any claim that I believe there's a strong difference here. Thought, are we sure that there's some kind of difference there or not? I don't know. What did the thought... yeah, maybe. Okay. So the more characters are portrayed as thinking in thought bubbles, the more likely an issue is to pass the Bechdel test. Okay, so so we were able to use the same approach here of using the bootstrap resampling and then training lots of models to answer two very different kinds of questions.
All right, we did it. There aren't a whole ton of issues in the Claremont Run of the Uncanny X-Men, and so we used bootstrap resampling to be able to make robust estimations using the data we have to understand what are the relationships between, for example, how often these characters are portrayed and whether that issue takes place in the X-Mansion, or for example, how often do characters speech, how many speech bubbles are there, and does an issue pass the Bechdel test? Bootstrap resampling and other resampling methods are powerful methods to have in our toolkit as people who work with data, and I really like that we were able to walk through and show how to use this. I hope this was helpful, and I will see you next time.